Today we are doing the quadratic formula again, but today we're going to see some i's, which are a part of our complex number system. Okay, so let's get this formula down so we remember what it is. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So that's our quadratic formula. Remember, we need these problems to say equals 0 before we begin. So, is number 1 ready to go? Nope. All right, let's leave the 2x squared alone and let's move the minus 6x and the minus 7 over. So what's the left side going to say? It's going to say 2x squared plus 6x plus 7. Very good, equals 0. So off to the side, let's identify a, b, c, and b squared minus 4ac, just like we were doing in the previous lesson. All right, so who's a this time? 2. Who's b? 6. Who's c? 7. And now we want to calculate b squared minus 4 times a times c. All right, so I know that b is 6. I know that a is 2. And I know that c is 7. Okay, so time for the calculator. Dun, 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 dun. And I'm going to type that in. So we've got parenthesis, 6, close it, square it, minus 4, parenthesis, 2, close it, parenthesis, 7, close it. So 6 squared minus 4 times 2 times 7. And that makes negative 20. Okay, so that is our discriminant. That's what that's called, that b squared minus 4ac. Okay, so now let's do the formula. So x equals the opposite of b. What's the opposite of a positive 6? Negative 6. Plus or minus square root b squared minus 4ac, that made negative 20, all over 2a. And what's 2 times 2? 4. All right, so remember, once you get to this point, you start working on your square root. And you have a negative. So remember, every time there's a negative under the square root, I takes it out, and then you're left with a positive 20. Now, if 20 was a perfect square, we'd take the square root of it, but it's not, so we want to break it down. So who's our largest perfect square that can go into 20? 4. How many times? 5 times. And then what's the square root of 4? 2. So it's 2i square root of 5. So we're going to rewrite this and replace the square root of negative 20 with 2i square root of 5. So here we go. We have negative 6 plus minus. This is getting replaced with 2i square root of 5 all over 4. So if we ever have a square root or an I, we can't get nice answers using the plus and the minus. So either we're done at this step or we can reduce. So look at your 3 front numbers. And can you divide those 3 front numbers all by something? Yep, we can divide them all by 2. So let's do that. So what is negative 6 divided by 2? Negative 3. Put your plus minus. What's 2 divided by 2? 1, so 1i, or just I. What's 4 divided by 2? 2. And then the square root of 5, bless me, sorry. The square root of 5 just recopies. And that's our answer. So basically what we were doing in the last lesson, except we have an I. So if you ever have a negative for a discriminant, you will end up with a negative under the radical, which means you'll have an I. So every time your discriminant is negative, there will be an I in the problem, making this a complex answer or an imaginary answer. Okay, looking at example 2. Is it ready to begin? Yep, it says equals 0. Okay, perfect. And this side's in order, x squared, x constant. So who's our a? 1. That's the number in front of the x squared. Who is our b? Negative 2. b is the number in front of the x. Who's our C? 3. Okay, now we need to calculate the discriminant, the b squared minus 4ac. All right, so I need parentheses where my b is, parentheses where my a is, parentheses where my c is. Okay, so we know that b is negative 2. We know that a is 1. And we know that c is 3. Okay, Mr. Calculator, come here. Now, if I didn't have a calculator, I could do this with order of operations. I haven't done that so far because people tend to make mistakes. So I've just been using the calculator. But if you had to use order of operations, you could. Okay, and that gives us negative 8. All right, so that's our discriminant. So once again, since our discriminant is negative, we're going to have an I in this answer. All right, so now formula time. So x equals the opposite of b. What's the opposite of negative 2? Positive 2. Plus or minus square root. This is your b squared minus 4ac all over 2a. And what's 2 times your a? 2 times 1 makes 2. Okay, once we get this far, we start working on our square root. All right, because of that negative, we need to use an I. So I is going to take the negative out, leaving a positive 8. And then you can't take the square root of 8, so we need to break it down. So do you know who the largest perfect square is that goes into 8? It's 4, and it goes in there twice. So what's the square root of 4? 2. So it's 2i. And then recopy square root of 2. So we're going to rewrite that, replacing it with 2i square root of 2. So I've got 2 plus minus. I'm replacing this with 2i square root of 2. And then all over 2. Okay. So at this point, I'm just looking to see if I can simplify it a little bit. If I look at these 3 front numbers, can I divide them all by something? Yep, I can divide them all by 2. Now that's been a kind of a common theme is dividing them all by 2, but sometimes you can divide them all by 4, sometimes you can divide them all by 3. It just depends on the number combination. Okay, now this is something that people will mess up. So 2 divided by 2 is 1, and people think you don't have to put this 1, but there's nothing behind it, so you have to put the 1. So 2 divided by 2 is 1. Put your plus minus. 2 divided by 2 is 1. Now this 1 you don't have to write because there's an I behind it. And then in the denominator, 2 divided by 2 is 1. Now I don't have to put a 1 in the denominator because there's always understood to be a 1 in the denominator. And then the square root of 2, recopy it. So let's talk about the 1s. You don't have to write 1s if there's something behind it. And you don't have to put 1s in the denominator. But this 1 that's in front, you have to put that 1 because there was nothing else there. Okay, let's do one more on this side. I don't think we need to do all 4. All right, is this one ready to go? Nope, it needs to say equals 0, so we're going to move the minus 4. So it's going to be 3x squared plus 2x plus 4. Because to move a minus 4, you have to do the opposite and add. Okay, so off to the side, I want to find a, b, c, and b squared minus 4ac. So a is a 3, b is a 2, c is a 4. Okay, and then I need to calculate my discriminant, my b squared minus 4ac. So b is 2, a is 3, c is 4. Okay, so b squared minus 4ac. Here we go. Parenthesis 2 squared minus 4 parenthesis a parenthesis c. And that makes a negative 44. Okay. So let's do our formula. Here we go. X equals the opposite of b. What's the opposite of a positive 2? A negative 2. Plus or minus square root. B squared minus 4ac is negative 44. All over 2a. And 2 times 3 6. Okay, time for the breaking down of the radical. So there's going to be an I to get the negative out, and then a positive 44. And then, can you take the square root of 44? Nope, but we can break it down. Who's your largest perfect square that can go into that? 4 can. How many times? 11 times. And then what's the square root of 4? 2. So it's 2i square root of 11. So that's going to get replaced with 2i square root of 11. So I've got negative 2 plus minus, replacing with 2i square root of 11, all over 6. Now, I do want you to know that sometimes these 3 front numbers can't all be divided by something. And if they can't, then that's the answer. But once again, I can divide all these 3 front numbers by 2. So what is negative 2 divided by 2? Negative 1. 2 divided by 2? 1. Now I don't need to put the 1. And 6 divided by 2? 3. And then our square root of 11, just recopy it. Okay, so there's only one other thing I want to do with this lesson, and that's talk about the discriminant a little bit. Okay, so the discriminant is our b squared minus 4ac. If when you calculate it, you get a positive number, that's what greater than 0 means. You get a positive number. You get 2 real solutions. So if I show you an example from the other day, when my b squared minus 4ac was a positive number, do you see how I have 2 answers? And the reason they're real is because there's no i's. So here my discriminant was a positive number, and once again I had 2 real answers. Even these guys, this is still positive, it's greater than 0. I still have 2 real answers. This is negative 2 plus 3 square root of 2 over 2. And this is negative 2 minus 3 square root of 2 over 2. So I still have 2 answers, and they're real answers because there's no i's. Okay, so the previous lesson, our discriminant was always bigger than 0, it was always positive, and we got 2 real answers. So if I was to graph any of those, you would see the graph touch the x-axis twice. That's what it would look like visually. Now, in the previous lesson, I never actually worked any where the discriminant was exactly a 0. But I want to talk about it. If our discriminant was exactly a 0, I'm just going to make something up. So let's say we had this, and then our discriminant, remember it goes under the square root. Let's just say I had this for an answer. So then if I was to do this, what is the square root of 0? 0. And then I'd be able to work it with the plus and then with the minus because there's no square roots or i's. So if I did the plus, what's negative 4 plus 0? Negative 4. And what's negative 4 divided by 2? Negative 2. Now let's do it with the minus. What's negative 4 minus 0? Still negative 4. And negative 4 divided by 2? Still a negative 2. See how you only get one answer when your discriminant is a 0? There's only one. So that's what this is saying. When your discriminant is exactly a 0, you only get one answer, which means visually this graph would only touch the x-axis once. And then today's lesson, our discriminant was less than 0. So less than 0 means you're getting a negative number. So if your discriminant is a negative number, like what happened today, our discriminant was a negative number. We got 2 answers, but they're imaginary answers because of the i's. So when your discriminant is a negative number, you get 2 imaginary solutions or 2 complex solutions. And visually, these graphs don't touch the x-axis at all. Okay, so in these 3 problems, all I want to do is find this says determinant, but it should say discriminant. Sorry, that is a typo. We want to find the discriminant and then tell how many and what kind of solutions they are. Okay, so I still need these to say equals 0 before I begin. So if they don't, we'll have to fix them. And so all I need to calculate is b squared minus 4ac. Hopefully at this point we can kind of do it with our calculator without writing anything down. Let's try. So b squared minus 4ac. So parentheses, who's the b? 6, close it, square it, minus 4, parentheses, who's the a? 1, close it, parentheses, who's the c? 9. So my discriminant is 0. Okay, so when the discriminant is 0, then we know that there is one real solution. So we don't actually have to solve it. We just are trying to figure out how many solutions it would have. And it would have one real solution. Okay, let's try it again on this one. But is it ready? It's not ready. We need to move the 5. So this is going to say x squared minus 4x minus 5. Okay, so now let's find our discriminant. So let's calculate b squared minus 4ac. Let's see if we can do it without writing anything down. Okay, so I'm going to have parenthesis, b is negative 4, close it, square it, minus 4, parentheses, our a is a 1, parentheses, who's c? And negative 5. And we get 36. Okay, so if our discriminant is a positive number, then we get 2 real solutions, meaning they won't have i's in them. So we have 2 real solutions. Okay, and then example 3. Is it ready to begin? It is. Okay, so let's find our discriminant, our b squared minus 4ac. Okay, so parenthesis, our b is a 6, close it, square it, minus 4, parentheses, our a is a 1, parentheses, our c is a 10. And that makes negative 4. So our discriminant is a negative 4. And anytime our discriminant is a negative number, we're going to get 2 imaginary solutions or 2 complex solutions, however you want to think of it. So 2 imaginary solutions. So this was us not actually solving them, but telling what kind of answers we'd get if we were to solve the problems. And that's all for this lesson. Smiley face.